Welcome to this next video. In this video, we'll be dealing with integration of trigonometric functions. And I think it is absolutely essential that we get to do this because this is one of the more important concepts in further studies in mathematics. So let's dive right into it. So what will be essential in trigonometric functions is to realize that, one, you are given the formula sheet. And in your formula sheet, you are given what happens if you've got a function, and in its on the other side, you have what its derivative is. So remember that when we're integrating, we move from the side of the derivative, and then we just transition over to the function. And I think it is absolutely important that you are able to do that. And then in some situations where we will be using substitution, it is important to also remember the rule for integration. I'm sure you are well versed at that at the moment, and therefore it's quite important for you to use. The next thing I want to remind you of is that we've got these identities now. In many ways, we'll call these square identities. And because they generally have powers of 2 there in general, so we'll call them square identities. So these are essential. So a combination of the table from your formula sheet, these identities, and also the integration rule. That's what we'll be able to use in this particular video. So let us say we're given basic equations like what is the integral of cos dx. So the integral of cos, we will come to this side of the table. We can identify causes there, and therefore going backwards, that gives us a sine. So therefore the integral of cos x simply becomes the sine of x, and make sure that you remember your constant for integration. And that is exactly it. There is nothing more that you need to do there. So let us look again into the next one. You can see here we're looking for the integral of sine of x. So what we can see that we don't necessarily have sine of x, but we have minus sine of x. Is there another way of writing positive sine x using an expression of sine x? Yes, I think you've guessed it right. So this, we can put a negative outside the integral, so negative times negative. So this gives us negative sine x. So from here, we can clearly see the one part is cos of x. So therefore, the integral of negative sine x, if we go backwards here, it gives us cos of x plus your constant of integration. So you can merely use this, or just remember that you have minus sine x, and when you're differentiating, simply put a negative before the cos x, and that would be one way of getting that done. The next thing I'd like to do is the integral of sec squared of x. You can see that sec squared of x is there as a derivative. So it means that if we go backwards, it gives us tan x, and therefore the integral of sec squared x is just tan x. And therefore you can go tan x plus the constant for integration. So integrating trigonometric functions can be quite easy, but also it can be a little bit more involved, as you will see with the next examples that we will do. So let's look at this next one. We're looking for the integral of tan squared of x. So tan x squared of x, or tan x squared, we can see that there is no tan squared anywhere in our derivative side of the table. So what we will do, we will then come back and use our identities. So we then identify this identity over here, which is the one that's got tan, and then we'll just rearrange that by taking the 1 to the other side. And therefore, by taking 1 to the other side, we'll have that the tan squared of a is equals to sec squared of a minus 1. So that's what we'll do. So wherever I find tan squared of x, it means that I can substitute using the identity. So I now get sec squared of x minus 1, everything with the dx on the outside. And therefore, it's quite easy for me to now find the integral of sec squared. You'll see that the integral of sec squared is tan x. So this becomes tan of x. And the integral of 1 is simply minus x plus the constant of integration. And there we are done. And this is how we'll be able to integrate tan squared x. Remember to use the identity. The next thing I'd like to cover is this particular question with the cos of 3x. So cos of 3x. So here we can come back and use the u substitution that we learned. And after we use this u substitution, I will tell you a little trick. So here we can start by saying let u equals to 3x. And therefore we take the derivative of u with respect to x. And therefore this just gives us 3. And what we'll then do, we'll just rearrange this to give us du is over 3 is equals to dx. And you'll see exactly what this does for us. So what we'll do, we'll just rewrite the integral now. So this becomes the cos of 3x and then dx. So from here, we are able to see that wherever we find 3x, we can substitute u, and you'll be able to see this quite nicely. So this becomes the cos of u, and then wherever we find dx in the original expression, we can write it as du over 3. And this expression is merely, you can put 3 outside as a constant, and then all that you are doing is finding out what the cos of u is. Now our integral is in terms of u, and therefore it makes our life so much easier to do. Now let's go back to our table. We've got cos. We know that the integral of cos is going to be sine x, and therefore we have 1 over 3 multiplied by the sine of u plus the integration constant. And therefore what you want to do is to sub back. You want to sub back what u was. So our final answer remains the sine of 3x over 3 plus c. So obviously I've gone the long route around this. I just wanted to show you where this comes from. But a lot of the times when you've got a basic trig ratio like a sine or a cos with a number before it, you can simply just go sine 3x divided by 3, and we'll be able to do that in our next question here. So just a reminder again, we now have the integral of sine. So instead of going about the u substitution, we can use the little discovery that we just discovered in that particular question. So in order to answer this question here, we'll say, okay, we know that sine has to be negative, so therefore we know that our answer will be negative. So therefore this becomes negative cos of 4x, and then we divide that by 4. And therefore, if you had to use the u substitution going the long way about this, you will still get the same solution. So therefore, if you've got a basic trig ratio, all that you can do is divide it by the coefficient of x there, and then substitute it there, and therefore that is the solution that you get. So just a reminder, with integration involving trigonometry, it is absolutely essential that you use your formula, which is given on the table, which is given on your formula sheet, and therefore continue to use all the basic knowledge that you know about trigonometry and your u substitutions. In the next video, I will be covering more u substitution type questions using trigonometry. So see you in the next video.